Hello everyone, this is Logan. I am back with this. This is what I am hoping is the final iteration of my go-kart's control box. And I wanted to bring this to you as well as an update as to how the go-kart's coming and a teaser for another project I'm working on that should be coming up relatively soon. All right, so let's start where we left off. Where we left off was those transistors all blew up. This is if you haven't seen my other videos recently, or I shouldn't say recently, last year, early this year. I then replaced them with these IGBTs inside of this heatsink. There's all the thermal paste. And they weren't working. They were shutting off randomly at different voltages. So I have completely redesigned them. You can actually see my little simple test motor is running right there, showing that it's working. And this is what I've come up with. So I've been hard at work redesigning just about everything about this box, and it's actually not quite done. There's one more feature I'm going to be adding. But let me run you down through everything that we got here. So we got the battery in this wire right here. And so because the go-kart has two sets of batteries, there's one going to each one. Same thing with battery return or 0 volt right there. All right, inside the control box, what we have is the power comes in down there. It then goes to each of the relays. You can see right now that's phase 1 relay is working, P1. So it goes to 2 plus, goes through the relay when it turns on to 1 minus, goes out to the connector, into the coil, back into here. I'm sorry, down there. Okay, this is the other side of it, and I'll explain why that's there in just a second. It's also going through a fuse, so technically it's going in from this. This right here is called DIN rail, and these connectors are just DIN-nectors or DIN connectors. Very, very handy. We use them a lot at work, so I decided to buy my own. Those little yellow things are jumpers, so this whole terminal block right there is connected. So is that one, etc., etc. I got labels, but you can't really see them. Goes in through there into the fuses. So if these relays do decide to blow up again, I've got 30 amp fuses right now in each one, and there's 2 of these for each phase. So in theory, I could have 60 amps going through each phase. All right, so what do I have here instead of IGBTs? These are a set of DC-DC relays. So they're controlled by anywhere from 3 to 32 volts. That's coming from the Hall sensor, which I now have at 15 volts from there. So what happens is power comes in here, it goes to the 15 volt regulator, out to 15 volts. From there it goes into the 5 volt, but I'm not actually using 5 volts anymore. The reason I put that in was because the IGBTs needed a 5 volt gate. I don't have to worry about that anymore because these can handle up to 32 volts control. So it goes from the Hall sensor in here. Now one of the problems I found out with the Hall sensors is the difference between syncing and sourcing voltage. So, or current rather. So what I was assuming, and before when I hooked them up to my transistors, it wasn't a deal at all. I was assuming that they were outputting a positive voltage. I mean, we have positive, we have negative, and then output I just naturally assumed was positive voltage. In fact, it is not. It is not outputting any current whatsoever. In fact, it's outputting a negative voltage, which means it's actually drawing in or sinking current. Sourcing means it's a source of current or electrons. In this case, it's sinking them, so it's the current's actually going into the sensor and then also coming out of that 0 volt or the ground line. That was the big thing that was holding me up. Once I realized that, I could, instead of controlling these relays with positive, I had to connect the Hall sensors to the negative. So basically positive is coming into and out of there. And then we also have positive coming in here and going from here back to the sensor, which then returns on that line. That was what allowed the whole thing to start working. These particular relays are from a Chinese company called Photech. Now, I'm going to issue a word of caution here. I've heard plenty of horror stories with Photech relays being counterfeit. In other words, Photech's a real company, But let's see if I can get this out here so you can actually see the name here. Votech is a real company, but there's plenty of knockoffs. And what they'll do, they'll actually use components that can only hold, you know, half or a third of what they're actually rated at. So in this case, they are rated at 100 amps. However, even if they can only do half, that's fine because I can only have 60 amps going through there based on my fuses. So that's fine. As you can see, they're working. Got my fans blowing, and there's two more fans that are going to be right here blowing out. Got these awesome heat sinks, so any heat that's being produced is dissipating. And even just feeling this here, it's actually decently cold. So the fan's keeping it decently cold, even though it's not blowing directly on it. Once I get the actual top on here and the other side where the fans are sucking air out, they're going to keep it nice and cool in there. So you can see that they're working. All right, this leads me into the next thing that I want to teach you guys about, which is called a flyback diode. What's that for? You can see it's actually set up opposite to the direction of current. So what happens is you've got positive current coming in from the source to the motor, out through the control, which in this case is these, and then back out to the ground or 0 volt line. But you got this flyback in here, which is basically facing the opposite way. Don't look at any of this. I was just making notes as I went. This is because when you energize a coil, okay, every time you energize this coil, energy has to go into the magnetic field, and it gets stored there. It's literally wrapped up in this magnetic field that's being output. Well, as soon as the Hall sensor turns off the current here, but all that energy is still there. It has to dissipate somehow. The way it normally dissipates is it actually feeds backwards. So if current is going in one way and out the other, it tries to feed backwards through where it would normally go in. What that means is it actually feeds backwards into these relays. And that can be a huge source of the relays blowing up. I am almost positive, besides just the fact that I had too small of relays, I'm almost, Darlington transistors as it were, I'm almost positive that's what happened to those, is that the amperage was so high in the coils in the motor that it actually fed back into those relays, or into those transistors, and blew them up. That's why the one started on, boiling. So this is a flyback diode circuit, and my flyback diodes are right here. Let's see if I can get a good look at them. Here we go. Okay, so there's actually 3 prongs because you could use these as 2-in-1s. The middle is the common, and each side is isolated from the other, so you could have one here and one here sharing this common. Being how big these relays are, I didn't want to share them, and these things were not terribly expensive at all. In fact, I will put the part numbers in the description in case you guys want to take a look at it. Now watch this. You can actually even hear it happen. As soon as I touch this, I connect that flyback diode, you're going to see this go down. Do you hear that slow down? No, wait, when I let it go. You can hear the sound change. And let's actually take a look at what it's doing. Right now, we're at about 1600 RPM. Now, if I connect this, see if I can get it stuck on there. There we go. Now, we take a look. 1300 RPM. It's actually slowing it down, but the reason for that is because this Hall sensor is turning on so fast, on and off, on and off, on and off, that the energy in the coil doesn't have a chance to dissipate. So when it turns back on, there's already some energy there. It doesn't take as long to ramp back up. So with the flyback diode disengaged, the motor can actually spin faster. But with the higher voltages and higher amperages, you're more likely to damage your circuit. So that's why I'm putting the flyback diode in there, and I will absolutely sacrifice some speed for safety here. and longevity of my components. Now also, being 1600 RPM, my wheels on my go-kart are never going to be turning 1600 RPM. They're just not. They'll never go that fast. So I don't actually have to worry about that. So even if I do lose, say they're spinning at 300 RPM and I lose 30, it's not going to be a huge deal if I can actually get the go-kart moving. So this is how you wire it up. Effectively, I got, let's see, we got the power on the 1 minus is going to be going into the center of the flyback. In fact, here I've got a little diagram. So this is technically the positive, and this is the common. So the commons are wired up here. So here's how it works. Power comes in through the battery, from the battery, goes out on 1 negative to the coil, and from the coil the other side goes back to the battery. Now, from where it goes to the coil, you also run it through the common, and then from the positive back to the battery. That will give you protection to your circuit. Now there's one other thing I'm working on as well, and that will be the source of a future video of how it works, which is how a current limiting circuit can work. So what eventually is going to happen is there is going to be a current sensor on here. Current will flow, it'll basically be clipping this in half. Current will flow out of here to the sensor, back here, and then back into the coil. What that sensor does is output a voltage, 0 to 5 volts. And I'll explain this more in that future video. And that sends it out, and you can either use a comparator chip or a microchip. And when that voltage hits a certain level, it will cut off the signal from the Hall sensor, effectively shutting down the circuit whenever the voltage, or whenever the current gets above some limit that I preset. So that's very, very exciting, and hopefully it'll allow me to get rid of the fuses or simply use them as backup and have something that is resettable continuously. Guys, there's plenty of fun things to come. Effectively, right now, I am waiting on rebuilding the motors. In fact,